Take out your notes under exponents, please. And the little subheading, children, is negative exponents. Negative exponents. Boys and girls and ladies and gentlemen, we have done this so far. 2 to the third power. And you know what that means. What does 2 to the third power mean? It means you have 3 2's times themselves, which gives you 8. All right. But today we're going to investigate and think about what is this all about. What is 2 to the negative third power? Any speculations as to what the answer that might be? I suppose the first thought somebody would say would be negative 8. All right, to which I'm going to give you the number one point of today's lesson that people usually make a mistake on. Write this down in completely understandable terms. Negative exponents have nothing, I repeat, nothing to do with making your answer negative. Okay? A negative exponent has nothing to do with making your answer negative. As a matter of fact, the answer to this is not negative. If it's a negative, I mean, it's not even. So get that kind of out of your mind, because that seems to be something that everybody comes up with. And I am just going to tell you how this works. I could give you kind of the explanation, but I don't know if it's really worth the time it would take. Maybe, maybe not. Should we go, Brady? Do you really think you want to know what this?
I mean, if it's important, but less.
Well, Brady, that's here. Let me just give you this first, and then maybe Brady will talk and give you the gist of this here. First of all, negative exponents are not your friends. We don't deal with negative exponents. There's only one thing, and the reason they're giving you this now is because we're talking scientific notation, which uses negative exponents. Everything else, we never use that negative exponents. I mean, they're just bad. They are B-A-D, bad. So we need to make that negative exponent a positive exponent, and this is the simple rule of thumb. To make a negative exponent positive, comma, you move the base and the exponent. I'm just gonna exponent from either top of a fraction to bottom, or vice versa. Again, this will make not a lot of sense to you until we do an example, and that's why we do examples. And I don't know why I have to do this on the bottom of the page as opposed to the top, but that's the example. Okay, that simply means this, children. Don't let this confuse you, River. 2 to the negative third power, I need to make this positive. And the way I do it is I take this whole thing. First of all, think about this as being a fraction. You can make anything a fraction by putting it over 1. To make that a positive exponent, I take this whole thing and move it. It's on the top. I take it and I put it on the bottom, and it becomes 2 to the positive third power on the bottom of the fraction. What's left on top? Well, we can't leave tops of fractions blank, so we put a 1 up there. So believe it or not, 2 to the negative third power is the same thing as 1 over, what is 2 to the third power? 8. So 2 to the negative third power is 1/8. This is actually what it means. 2 to the negative third power is 1/8. Again, We'll talk about it in a minute. 4 to the negative 2 power would be what then? Using the same logic, I need to move it to the bottom of a fraction. It equals 1 over 4 squared. And that would make it, Charlie? 1/16. If by some chance you had this, 1 over 5 to the negative 2 power, I don't think they'll give that to you because they don't really throw in this at you just yet. You take this whole thing, base and its exponent, move it to the top of the fraction, and it becomes 5 squared. At 5 squared, you could put it over 1, but it isn't going to change it, is 25. Now, here's where Brady says, please explain to me why that is.
Please explain to me why that is.
Well, let's look at this here. If you remember, did we do this before? If you had 5 to the 8th power over 5 to the 6th power. Have we done that maybe before? Oh, well, just know this is this, right? 5 to the 8th power is 8 5s, correct? How many is that? 1, 2, 3, 4, 5, 6, 7, 8. And 5 to the 6th power is 6 5s, right? And when you have the same numbers on top as on bottom, Charles, wake up. What happens? They cross off. What am I left with? This 5 and this 5 crosses off, that 5 crosses off, those 5s cross off, those 5s cross off, those 5s cross off, and those 5s cross off. What am I left with on top? What is that? 5 to the 2nd power, which is 25, but let's just call it that. So, the rule is this. You see this was an 8 and this was a 6? I subtracted 6 from 8. I mean, I could have done it quicker just by saying 6 from 8 is 2, correct? Well, here is your epiphany moment. Here's where the light bulb comes on. Let's say these two numbers were flipped over, and I had 5 to the 6th power over 5 to the 8th power. Same rule applies. I subtract the bottom from the top. What is 6 minus 8, Riv? -2. There's my negative exponent. But if I did it like this, these things would be flipped over. I would have, wait, stop, I gotta do this. What do I have to do? I gotta do this yesterday. Task manager, where's it at? Was that task manager? Why is it so, what's using all my stuff? Apparently Chrome is. Let's see how many Chromes disappear. Another one. At one point they'll all go away. Are they still there?
Yeah.
Maybe people should stop having so many tabs open. Oh, there it is. They're all there now. How about that? Huh? So back to this. If these things were flipped over and I had how many on top? If I have 6 5s on top and 8 5s on bottom, what's going to happen? All of these 5 are going to cross off, or all of those 5 or 6 5s are going to cross off with 6, and what's going to be left on the bottom? 2 5s. What's left on top? A 1, and what is 5 times 5? 1 over 25. And what is this? 1 over 25, because we put it to the bottom. Now, that's all completely immaterial, whether you understood that or not. Today, we're doing it because we use this in scientific notation. Okay? And the only thing you need to understand is this. In scientific notation, we always use tens with exponents. 10 to the negative 1st power, 10 to the negative 2 power, 10 to the negative 3 power, 10 to the negative 4 power. What do those mean? It's pretty simple. Well, 10 to the negative 1 power is the same as what fraction? 1/10. 10 to the negative 2 power is the same as what fraction? 1 over 100. 10 to the negative 3rd power is 1 10,000. 10 to the fourth is 10,000, and so on and so on. Because now you need to take out your notes under scientific notation. So this is where this comes to play. We've done really big numbers in scientific notation, but today we talk about small numbers. But the rules are still going to be the same. Let's say I've got, well, let's do a big number first, just so we review the rules. Remember the rules of scientific notation, 3, 8, 0, 0, 0, 0, 0, 0. What were the rules of scientific notation? Step number 1 is you make the number between 1 and 10. So what do I have to do here? I need to move the decimal from here to where? To right here, right? So my number becomes 3.8. Rule number 2 was I write down times 10. And then step number 3 was to do what? How many places I moved the decimal is my, we did do this before, didn't we? It's my exponent. I moved it 3, 6, 7 places. So this is this in scientific notation. Hopefully that's a relief for you and I don't need to do that. Well, today we're not doing big numbers, we're doing small numbers that look like this. 0.000000024. Okay. The rules are the same. I need to move my decimal so that it becomes a number between 1 and 10, which would put my decimal where? Brendan Massey? Right, it goes all the way from here. I move it all the way there. My number becomes 2.4. I still write down times 10. Okay. But to get my exponent there, I still do the number of places I move the decimal, which happen to be what? 1, 2, 3, 4, 5, 6, 7. But guess what? It's not 10 to the 7th, but it is 10 to the negative 7th. Because what that really says is this. I am taking 2.4 and multiplying it by 1 over 10 with 7 zeros over it, under it, I'm sorry. And if I did that, I would end up back with this thing here. Because this is a negative exponent and makes a fraction with whatever that is, 10 to the millionth power or whatever that is, 10 to the millionth, 10 millionth, whatever that is. So do you see that? The difference between big numbers, positive exponents, decimal numbers, big long decimal numbers give you negative exponents. Another example would be 0.002, that's not 2, 0.00936. In scientific notation, that would be, who's got a guesstimation for me there? Kevin Wills?
9.36.
Absolutely. Times 10 to, what's my exponent? That's probably the most important thing. How many places did you move the decimal?
10 to the negative third.
Yep. You moved it 3 places. 1, 2, 3 puts it right there, so it's negative 3. As opposed to 93600, which would also be 9.36, but this time it is 10 to the what power? Fourth. 1, 2, 3, 4. See the difference there? Or if I asked you this, let's say I've got this, 7.8 times 10 to the negative 10th power. What would that number be in standard form? What would you do? Well, you know you're gonna move the decimal how many places? 10. In which direction am I gonna move it? Left. I have to make it. And the easy way to kind of do this without really counting is one of the 10 places gets taken up there. So how many zeros am I going to have to add? 9. So it's going to be 0.1, 2, 3, 4, 5, 6, 7, 8. 9 zeros, 7, 8. So it's going to be digits there. And so these are going to be small digits there. Not that exciting. Let's see what we got here. Did they give us negative exponents here? Oh yeah, now go back to your negative exponent thing there. Sorry, I gotta go back and tell you this, but I didn't realize you did this with this. And write down one more example here. This is where things get really dicey, by the way, children. Here is directions. Directions say to simplify. Ready? X to the negative 3, y squared, x, y to the negative 1. What do you think you would do there? River, you seem to be looking perplexed. First of all, remember my words of advice there, Brendan Massey. Negative exponents are not your friend. How do I make and fix negative exponents so they become your friends? Make them positive. How do I make them positive? I either move them from the top or the bottom, depending on where they're at. So this thing is the same thing as I need to take this and move it to the bottom of the fraction because it has a negative exponent, so it becomes x to the positive thing. Y squared is already positive, so it can stay on top. This x is a positive 1, so it can stay on top. But this y is negative 1, so it becomes on the bottom. It becomes y to the positive 1. Dost thou understand what I just did there? What part, Ephraim? If you take a base and its exponent and move it from the top of the fraction, which this is right now, to the bottom, the exponent becomes positive. All you do is move from top to bottom. This y to the negative 1, it was a negative exponent, so I put it on the bottom, it becomes positive 1. These already had positive exponents, so they can stay where they're at.
Oh.
You're just moving from tops to bottoms or bottoms to top, it just changes the exponent. Charles, what part doesn't that make sense to you? Well, you're looking perplexed at it. Now, if you think that this is the answer, unfortunately, we're still not done. Why? Because you can get letters to cross off here. You have two y's, y squared is y times y, and there's one y on bottom, so that will cross cancel with one of those y's. So you're left with a y on top. You have one x on top and three x's times themselves on bottom, so what's going to happen? One of those are going to cross off with one of that, and what are you left on bottom with? X squared. This would be completely simplified as much as you possibly can. I didn't say I liked it, but that's the way it is. I'm going to give you one more and then we're going to punt because this is getting ugly. Ready? 6. X negative 2, y 3. Z negative 1 over 2 x, y. And I'm going to let you try to flounder through that on your own and see if you get anything remotely close to what the answer is. But if you don't get this just yet, you are not alone, children. This is one of those things that seems like it's tough for people to pick up on. That's why, don't worry, it will come up over and over and over again. give you a second to figure, see if you can come up with something. Remember, your answer can never have negative exponents in it. The only place we ever see negative exponents in answers is scientific notation. Everything else is just pure craziness. Anybody want to speculate they may have the right answer? Somebody be daring. Anybody be daring. Somebody. Sam, I haven't heard from you in such a long time. Did you come up with anything? What? Daniel?
I got an answer.
Give me what you got. Don't be afraid, because most people are not going to get this. Just tell me what you
So
got.
on the top I have 4 and then y squared,
Or y squared.
and then under is x to the first and z to the first.
Right, we don't have to put the ones up there. Which I'm saying, I think you're mighty close, except for one small detail there. Anyways, you see the small detail where Daniel probably went wrong? Actually, more in the number end of things, Danny. 2 goes into 6 3 times. This is 6 divided by 2. You're not subtracting. This is a 3. But let's break this all the way apart. Here's probably how you should do this. First of all, let's make negative exponents positive. So I'm going to rewrite this just moving my negative exponents where they belong. So I'm going to keep the 6 on top, just for right now. Okay. And the 2 on the bottom. This x negative 2 is going to go, well, these are both positive, so I'm going to leave them there. I bring my x to the negative 2 to the bottom, it becomes x to the positive 2. I bring my z to the bottom, it becomes z to the first power. And my y cubed can stay on top. All I did there was made my negative exponents positive. Okay? Now, I can simplify this. 2 goes into 6 3 times, so this whole thing becomes a 3 on top. Y cubed, there's 3 y's on top and 1 on bottom, so that 1 y will cross off with 1 of the ones up top to leave me with a y squared on top. On the bottom, I have an x and an x squared. They're both positive, so they stay. What happens when I multiply x times x squared? I get an x cubed, and this z is positive, so it stays on the bottom. So when all the proverbial smoke clears, I get 3y squared on top, x cubed, z on the bottom. This is another one, Aiden, from where I say this is not hard to do, but it is very confusing. And the more you do it, the less confusing it becomes. It's just one of those things. How many did anybody actually have that? Oh, look at it. And if you need help on any of this, talk to Kevin Groves because he's nailed this. You will have plenty of opportunities, don't worry, for you to practice this.